Problem 101, we're taking a look at systems of equations. Both of these equations I'm going to go through, or both of these systems of equations, I'm going to use substitution to solve. So I'm going to take this top one right here, 2x plus y equals 12, and I'm just going to move the 2x to the other side. So it is y equals a negative 2x plus 12. And now I can use substitution. So x times negative 2x plus 12 will equal 16. This is going to be a quadratic, so I distribute. I get negative 2x squared plus 12x equals 16. So now I want to set it equal to 0 and solve. To get it equal to 0, I'm actually going to move all of this to the other side just so I have my leading coefficient positive. So if I do that, I will get 0 equals positive 2x squared minus 12x plus 16. Also, to make this a little bit easier on me, I'm going to divide both sides by 2, giving me 0 equals x squared minus 6x plus 8. So since it is an equation, I just get 0 divided by 2 equaling 0. It'll still give me the same roots. The only thing different is that this is no longer stretched by a factor of 2, but it does not matter for the roots or the x-intercepts. So now I can factor this. This is going to factor into x minus 4 times x minus 2. And zero product property will give me x equals 4 and 2. All right, once I have that, that means I now have to actually solve for y, because I have two solutions for x, so that means I'm going to have 2 coordinate points where these will intersect each other, where these equations will intersect each other. So I'm going to pick one of these, clear a little room for myself here. I'm going to pick the bottom one. So if I have 4y equals 16, y will be 4. That gives me the coordinate point of x is 4, y is 4. And the other one, if x is 2, so I have 2y equals 16, and y equals 8. So I have the coordinate point 2, 8. So these two equations will intersect twice, and those coordinate points are 4, 4 and 2, 8. That's sort of answering problem C here as well. That's what's happening. On to problem B, I'm going to do the same thing with that one. So again, I'm going to get y equals a negative 2x plus 12. The only thing different here is that this one equaled 16 and this one will now equal 20. So again, I will have x times a negative 2x plus 12, and that'll equal 20. Again, distributing, I'll have a negative 2x squared plus 12x equals 20. Again, moving to get it equal to 0, positive 2x plus minus 12x. Oops, sorry, that was positive 2x squared minus 12x plus 20. Again, dividing everything by 2. 0 equals x squared minus 6x plus 10. This problem cannot be factored, so I can do a couple different things. I could either complete the square, or I could go through and use a quadratic formula. I'm going to complete the square on this one because my leading coefficient is 1, and I have an even number for my b values, so it should be pretty easy to go through and complete the square. So I would be making an x squared with side lengths of x and x. I would have negative 3x's on both sides, and I would be adding 9 to complete that square. So I would have 0 equals x squared minus 6x plus 9 minus 9, because that's balancing it out, and plus 10. That is the square. So I have 0 equals x minus 3 squared plus 1. Moving the 1 to the other side, I now have a negative 1 equals x minus 3 squared. You might see right now that we're going to get into some imaginary numbers. So I square root both sides, giving myself, making a little bit of room here. So now this right here becomes I, and I'm going to have a plus or minus for that. So now I have plus or minus I equals x minus 3. And moving the 3 to the other side, I will get x to equal positive 3 plus or minus I. So what that means for this system is that they actually do not intersect each other. And those are the roots to solve it, but they do not intersect.